Welcome to another interesting lesson in basic calculus. In the previous lesson, we have learned how to find the derivative of a function using the delta method. We shall discuss the different differentiation rules to help us in finding the derivative of the function without undergoing a very tedious process such as what we have experienced in using the delta method in finding the derivative of a function. Let's have example number 1. Find the derivative of f of x equals 6. Now, since we have a constant function, we shall use rule number 1. If f of x is equal to c, then f prime of x is equal to 0. So therefore, the derivative of f of x equals 6 is 0. Now let's work on example number 2. Find the derivative of f of x equals x. So this is an identity function. Now the derivative of an identity function is equal to 1. Probably you are wondering why we got 1. So as you can see in the exponent, we have 1. And in the numerical coefficient, we also have 1. Now, to get the derivative of a function, especially an algebraic function, we will have to do the following. Multiply the exponent by the numerical coefficient. So 1 times 1 is 1. Now, all we have to do is to deduct 1 degree in the term. So we shall have 1 minus 1. So simplifying this, we will have 1 times x raised to 0. Now remember that whenever we have a non-zero number, raised to 0 is 1. So remember that the derivative of an identity function is 1. Now let's work on example number 3. Doing the same thing, we have to determine the exponent and the numerical coefficient. In f of x equals x cubed, the numerical coefficient is 1, while the exponent of x is 3. So all you have to do is to multiply the exponent by the numerical coefficient, so we will have 3. And we deduct 1 from the exponent in order to reduce the degree by 1. So simplifying, the derivative of f of x equal to x cubed is 3x squared. Now let's have example number 4. Doing the same as what we have done in the previous example, all you have to do is to multiply the exponent by the numerical coefficient. So this time the numerical coefficient is 2 and the exponent is 3. 3 times 2, that is 6. Then we deduct by 1 degree. So we will have f prime of x is equal to 6x squared. Now, what if we have f of x equals 2x cubed minus 3x squared plus 5? Now, all you have to do is to take a look at the rules. We shall use these rules if we have subtraction operation and then an addition operation. Now, applying what we have learned in the previous example, all you have to do is to multiply the exponent by the numerical coefficient. So we will have 6. Then we deduct by 1 degree. So we will have 3 minus 1. Repeating the same process, we will have 2 times 3, that is 6. And then x will have an exponent of 2 minus 1. Now remember that whenever we have a constant, the derivative is 0. Simplifying further, we shall have f prime of x is equal to 6x squared minus 6x. Now let's have example number 6. This time we have a product. Now looking at rule number 5, if f of x is equal to uv, then f prime of x is equal to uv prime plus vu prime. Now take note, u and v are functions. Let's say we have u equals to 2x minus 1, and then v equals to 3x squared plus 2. Now to get the derivative of u and v, all we have to do is to multiply the exponent by the numerical coefficient. So 1 times 2, that is 2. And we deduct by 1 degree. So since this is on the first degree, then we will have 0 degree. Now, any non-zero number raised to 0 is equal to 1. So simply, u prime is equal to 2. Now, for v prime, we will have 2 times 3. So we will have 6. Then deduct by 1 degree. So, and then the constant, we will have 0. So v prime is equal to 6x. Following the format, it says that the derivative of a product is equal to uv prime. Okay, so u is 2x minus 1, and then v prime is 6x. Then we have plus vu prime. So our v is 3x squared plus 2, and our u prime is 2. And then we just simplify by applying distributive property. We will have 12x squared minus 6x. In the second term, we will have plus 6x squared and then plus 4. So, simplifying, we will have 18x squared minus 6x plus 4. So the derivative of the given function is 18x squared minus 6x plus 4. What if we will apply FOIL method first and then we get the derivative?
Then we will have
2x times 3x squared. We will have 6x cubed. Then 2x times 2, that is 4x. And then negative 1 times 3x squared, that is negative 3x squared. And then negative 1 times 2, that is negative 2. So let's arrange the terms in decreasing powers of x. So we will have 6x cubed minus 3x squared plus 4x minus 2. Now getting the derivative of this polynomial by applying addition and subtraction rule, we will have f prime of x equal to 3 times 6, that is 18, then deduct by 1 degree, we have 18x squared. Then here, 2 times 3 is 6, then deduct by 1 degree, we have 6x, and the derivative of 4x is 4. Now take a look at our answer. Is it the same with what we have found a while ago? Definitely it's the same. Now, if you only have two binomials, you can use FOIL method to get the product and then apply the addition and subtraction rule for finding the derivative of the function. Okay. However, when you have a trinomial or a polynomial with more than 3 terms, that would be difficult or tedious. Okay. Instead, we have to use the product rule in order to have a shorter way of finding the derivative of a function. Now let's work on with example number 7. This time we have a quotient. So let's take a look at rule number 6. If f of x is equal to u, v, then f prime of x is equal to vu prime minus uv prime all over v squared. So let's start defining u and v. So u is the numerator, 2x squared, and v as the denominator. Then we will have u prime is equal to 4x, and then v prime is equal to 3. Now applying the rule, we will have, okay, VU prime. So that means we have to multiply 3x minus 1 times 4x minus u, that is 2x squared, then v prime, that is 3, all over 3x minus 1 raised to the second power. Now apply distributive properties. We will have 12x squared minus 4x minus 6x squared all over the square of 3x minus 1. Okay, we combine similar terms. Then we will have 6x squared minus 4x all over the square of 3x minus 1. Now let's take a look if we can cancel out something. By expressing the numerator in factored form, we extract the greatest common factor, which is 2x. Okay, so we will have 6x squared divided by 2x, that would be 3x. Now, negative 4x divided by 2x, that is 2. So let's see if we will have a common factor in the numerator and in the denominator. Okay, so unfortunately, we cannot cancel 3x minus 1 and
3x minus 2 because they are different.
so therefore, the derivative of the given function is the quotient of 2x times 3x minus 2 and the square of 3x minus 1. Now let's work on with example number 8. Find the derivative of f of x equals the square of 5x minus 2. Now since we have a square of a binomial, we can apply what we have learned in grade 8 about special products. So we can expand, okay, f of x will be equal to square the first term, that is 25x squared, square the last term, then we have 4. Now, to get the middle term, we multiply negative 2 times 5x, that is negative 2, and negative 2, that is negative 10x times 2, so we will have minus 20x. So we get the derivative using the sum and the difference, okay, and some other rules. So we will have 50x minus 20. Now, applying the this rule specifically, rule number 2, okay, we have our u, which is 5x minus 2, and then we have here, okay, simply we will have 2 times the numerical coefficient here is 1, so 2 times 1 is 2, and then we subtract by 1 degree, so 5x minus 2 is just, or we have to reduce by 1 degree, so this will be 1, and then we get the derivative of the binomial, so we will have 5. Therefore, f prime of x is equal to 50x minus 20.